Hello students, so in last lecture we discussed temp oscillation, okay, and its different numericals. So now today we discuss forced oscillation. Forced oscillation is also known as driven oscillation. Now students, before that first we discuss natural oscillation or free oscillation. Natural oscillation or free oscillation. Natural or free oscillation. So what is the meaning by natural or free oscillation, students? So natural or free oscillation means what? When a system oscillates without any external force, then it is known as free oscillation. Okay, when a system oscillate without any external force. When a system oscillate without any external force, then it is known as natural oscillation. And the frequency is known as natural angular frequency. See students, suppose we extend the pendulum and then release, then the oscillation is what? Natural oscillation, because they oscillate without any external force. Okay, so that type of oscillation is what? Natural oscillation or free oscillation. Now forced oscillation. Now what? Forced oscillation. So what is the meaning by forced oscillation, students? See, as we know, in the case of damped oscillation, amplitude of oscillation decrease with the time. So after some time oscillation becomes stop. So if we want to continue the oscillation, then external force is required. Then such type of motion is known as, then such type of oscillations are known as forced oscillation. Okay students, so if you want to continue the oscillation of pendulum, spring, then we need external force, we need external periodic force, that is known as forced oscillation. Without any external if external force is not there, then the oscillation are known as natural oscillation or free oscillation. If external force is present, then it is known as forced oscillation. Sure. When a system oscillate with external force, when a system oscillate with external force, then it is known as then it is known as forced oscillation. Okay, clear students? So first we discuss natural oscillation, then forced oscillation. So what is that external force, students? So external periodic force is given by external periodic force is given by F is equal to F naught cos omega t. F is equal to what? F naught cos omega t, where F naught is a maximum force. F naught is what? Maximum force. And omega is known as angular frequency, t is what? Time. Chalo, so what is the periodic force? F is equal to F naught cos omega t. What is the periodic force? F is equal to F naught cos omega t. Right? You can also write, students, F is equal to F naught sin omega t. You can also write F is equal to F naught. F is equal to F naught sin omega t. Chalo, so why here we take plus, students? Because this external force is in the direction of oscillation. Okay, so that's why here we take positive, plus force. So now see, students, in case of SHM, only one force is there, minus kx. Only one force is there, that is what? Restoring. In case of damped oscillation, two force, minus kx restoring force and minus bv damped force. In case of forced oscillation, there are three types of force. In case of forced oscillation, three types of force. Three force, minus kx restoring force, damped force and external force, that is in the direction of oscillation. Okay, so in forced oscillation, three types of force are there. Okay, restoring, damped force and external periodic force. Chalo, so now students, we already derived the differential equation of displacement for SHM, differential equation for damped oscillation. Now we derive differential equation of displacement for forced oscillation, right? Chalo, so obtain differential equation of obtain differential equation of displacement for damped oscillation. Okay, obtain differential equation obtain differential equation of displacement for forced oscillation. So see, students, we want to obtain differential equation of displacement for forced oscillation. So as we know, here three types of force are there: F1 plus F2 plus F3. F is what? MA restoring force, damped force and external periodic force. Okay, chalo. So MA plus KX plus BV, damped force, F0 cos omega t. Now what is the velocity? Is dx by dt, differentiation of displacement with respect to time. What is acceleration? dv by dt. What is velocity? dx by dt. So what is the answer of acceleration? d2x by dt square, d square x by dt square, that is the acceleration. Chalo, so what is now answer? What is speed? dx by dt, f naught cos omega t. Now divide by m. Now divide by what? M. So b by m, dx by dt plus k by m, f naught done. So this is what differential equation of displacement for damped oscillation. Differential equation of displacement for forced oscillation, d square x by dt square plus b by m dx by dt plus k by m into x, f naught cos omega t upon m. So this is what differential equation of displacement for forced oscillation. Now what is the amplitude, student? See, amplitude for forced oscillation. Okay, now we derive what? Amplitude for forced oscillation. What is that amplitude? A is equal to f naught m square omega square चलो स्टूडेंट्स आना न्यूमेरिकल्स नहीं आता सो डोंट वरी ओके एमसीक्यू नहीं आता आना बट फॉर्म्युला तो याद रखो दिस इज द एम्प्लीट्यूड फॉर forced oscillation. चलो now see what are the terms. F0 is a maximum force, m is a mass of oscillator, omega is what? Omega is angular frequency for natural oscillation, or it is known as natural angular frequency. What is the meaning by natural oscillation? Oscillation in presence, oscillation without any external force is known as natural oscillation. Omega d is angular frequency for forced oscillation. Forced oscillation means what? Angular frequency in presence of forced oscillation means oscillation in presence of external force, or forced oscillation is also known as driven oscillation. So that's why here we write omega d. So this is the amplitude. Now we define here resonance, students. Now here we define what resonance. So students remember students in alternating current in AC chapter you learn about resonance. याद છે બધાને? What is the meaning by resonance in that case? For particular value of omega, means when omega L equal to 1 by omega C, XL equal to XC, then current become maximum, IRMS current become maximum, then it is known as resonance in series LCR AC circuit. So in that resonance current become maximum, in that resonance amplitude become maximum. Okay, so when what is the condition? See, if both frequency are equal, means if your angular frequency for forced oscillation is equals to what? Natural angular frequency. It means તમે એટલો ફોર્સ અપ્લાય કરો કે oscillation never stop, continues, right? Then that is the example of resonance. Then amplitude become maximum. Okay, so that is the resonance where amplitude become maximum. So see, when both are equal, when your angular frequency for forced oscillation is equals to the frequency of natural oscillation, then see this becomes 0 because both are equal. So now B omega square 1 by 2 to cancel, so F0 upon B omega. So see, denominator becomes very small, only B omega, so denominator small, so amplitude become maximum. So that is known as resonance. Okay, so resonance means what? When frequency of forced oscillation is equals to the natural frequency, then amplitude become maximum, then it is known as resonance. And what is the maximum amplitude? F0 upon B omega. Okay, so this is the resonance in forced oscillation. Okay students, chalo. Now see students, this same equation you learn in alternating current also. Okay, શું હતી આપણે comparison કરવાની છે between electrical quantity and mechanical quantity. For mechanics or for mechanical quantity, what is the equation that we derived here? d square x by dt square, d square x by dt square, b by m dx by dt chalo. Okay, this is for what? Mechanical quantity. And for electrical quantity, For electrostatic, chalo, for electrostatic, what is the quantity? D square q by dt square plus R by L dq by dt plus q by LC okay. चलो, तो this are we learn in alternating current. Students, આનું તમને proof ન યાદ આવતું હોય તો કરાવી દઉં છું, જો ફટાફટ. See, in LCR series AC circuit, what is the formula? VL plus VC plus VR is equal to V. VL means voltage between two end of inductor. What is that voltage? DI by dt. What is the voltage of capacitor? C is equals to Q by V. है ना, for capacitor C is equal to Q by V, so V is equal to Q by C, then IR Vm sin omega t, or you can take cos omega t. Chalo, say then I is equals to what? dq by dt, because it is the differential equation of charge. This is the differential equation of displacement. So again here IR, so R dq by dt plus q by c. Okay, first we write this, then here. Chalo, then divide by L, so we get this. Okay, clear? Chalo, so now see how to compare these two things. Mechanical quantity, and here electrical quantity. Okay, mechanical quantity and what? Electrical quantity. Chalo, so see first comparison, students. Chalo, now we compare both quantity, mechanical and electrical. So first see it is X, then here Q. So here what? Here displacement X. So here charge Q. Okay. Then here dx by dt, then here dq by dt. Dx by dt means speed. Here speed v. Then here current I. Okay. Here speed, dx by dt means speed. So here dq by dt means current. चलो, then so our question केम पूछाय, which quantity is belongs to mass in electrostatic, your which quantities belongs to displacement in electrostatic, so that is charge. Then here B, so here R. B means what? B means what? Damped coefficient. So here we take what? Resistance. chalo then next see here M, so here L, so here M is mass, then here L means inductance. Chalo then see what is the next comparison? See in the M is what belongs to L, X then Q, है ना, X Q M L. So here K is left and here 1 by C is left. So here spring constant K, then here inverse of capacitance. આ થોડીક અલગ comparison, so remember it. In mechanical quantity spring constant K, so in electrical inverse of capacitance. Chalo and then see here periodic force, so here periodic voltage means here force is changed, here voltage is changed. Chalo in this case what is the formula for angular frequency? Root K by M. Here what is the formula for angular frequency? 1 by root LC. Okay, so this is the comparison table between mechanical and electrical quantity. Okay, now next students we discuss comparison between linear SHM and angular SHM. Okay, next is what? Comparison between linear and angular SHM. As we know, two types of SHM motion, linear SHM and angular SHM. Two types of simple harmonic motion. Linear SHM and second one is angular SHM. Okay, two types of SHM. First one is linear SHM, second one is angular SHM. So angular SHM means what, students? So in the case of angular SHM, in the case of linear SHM, body perform oscillation in a straight line, and in case of angular SHM, body performs rotational SHM, okay, in a circular path, rotational SHM. See, pendulum spring is an example of linear SHM, oscillation in a straight line. While simple pendulum perform angular SHM. Okay, simple pendulum performs angular SHM. Now see, we want to discuss the comparison. See, chalo, so now see, we want to discuss two types of SHM, linear SHM and then angular SHM. So what is the meaning by linear SHM? See, In linear SHM, force is there. In angular SHM, torque is there. Okay, here mass, then here I is what? Moment of inertia. Okay, then here K is what? Spring constant. Then here alpha is known as torsional spring constant. Okay, torsional spring constant means what? When any body performs, when any object performs angular SHM, circular SHM, then its spring constant is known as torsional spring constant. Okay, so here what is the formula? F is equal to kx. Then here what is the formula? In the place of F we write torque, in the place of K we write alpha, in the place of X we write theta. So torque is equal to alpha theta. Barabar? K is spring constant, alpha is torsional spring constant, X is a displacement, theta is angular displacement. હવે સી સ્ટુડન્ટ્સ આ ફોર્મ્યુલા તમે ક્યાં જોઈ છે? યાદ કરો, તમે આ ફોર્મ્યુલા ક્યાંક ભણ્યા છો? ક્યાં? તો કે આ ફોર્મ્યુલા તમારે આવી ગઈ છે ગેલ્વેનોમીટરમાં. ઓકે, ચેપ્ટર નંબર 4 ગેલ્વેનોમીટર. See what is the construction of galvanometer? Two magnet, between two magnet circular spring is there, and here on the circular spring rectangular coil is placed, and this coil is connected with the pointer, and this is the window. And students, so when current is, this is the initial position of pointer 0. When current is passing through the coil, torque is acting on it, and due to that it performs circular motion. So pointer shows deflection. આવી રીતના pointer જશે. So it is angular SHM. है ना, pointer આવી રીતના જાય. So it is angular SHM. તો એમાં તમે આ ફોર્મ્યુલા કદાચ તમે આમ લખી છે, ટોર્ક ઇઝ ઇક્વલ્સ ટુ, એમાં આપણે કે જ કીધું હતું પણ કે ફાઈ. સો ધીસ ઇઝ ટોરસનલ સ્પ્રિંગ કોન્સ્ટન્ટ, એન્ડ ફાઈ એટલે એમાં ડિફ્લેક્શન કીધું છે, આમાં થીટા કીધું છે. ઓકે, ચલો. સો ફોર એંગ્યુલર SHM, okay, for angular SHM spring constant is known as torsional spring constant. Now what is the unit of alpha? Unit भी change થઈ જશે. What is the unit of alpha? See, alpha means torque by theta. Alpha means what? Torque by theta. What is the unit of torque? Torque means what is the definition of torque? Perpendicular distance into force. So for force, what is the unit? Newton. For perpendicular distance, meter. So Newton. What is the unit of torque? Newton meter. And alpha is equal to torque by theta. Theta is the angular displacement, so radian. So what is the unit? Newton meter per radian. And here what is the formula of time period? 2 pi under root m by k. Then here what is the formula for time period? 2 pi m mass. So here I inertia, here k spring constant, here alpha torsional spring constant. Okay, so that is the comparison between linear SHM and SHM. Now see one example, students. It is from our textbook, question number 23 exercise. Okay, NCERT question number 23 from exercise. See what is that question? Very important question, students. See, there is one circular disc. What is the mass of the circular disc 10 kg. Now students, this circular disc is center of circular disc is connected with the wire. Suppose this is the circular disc, okay, this is the circular disc and this is the wire. Clear? Okay, આવી રીતના છે. This is the circular disc and this is the wire. Connect with the what? Center of disc. Now see students, wire is twisted. Now what is that given in a question? Wire is twisted by rotating disc and released. Okay, see students, when disc is rotated, then what? Twist is produced in a wire. આપણે કરીએ છીએ ને, આપણે સ્વિંગિંગ કરતા હોય હિંચકામાં, ત્યારે આપણે શું કરીએ? આમ હિંચકાને આમ કરશો તમે એટલે શું પ્રોડ્યુસ થઈ જશે? અહીંયા ટ્વિસ્ટ, વર્ડ twisted. Okay, so when we released, it perform angular SHM. Okay, so here disc is rotating and twist is produced in a wire, then is released, then it perform angular SHM. Okay, and what is the time period? 1.5 second. Find torsional spring constant of wire. So clear, we want to find torsional spring constant of wire and see when disc is rotating, okay, twist is produced is wire, and when released, so it performs angular SH. Okay, clear. હવે ઘણાને એવું હોય કે સ્પ્રિંગ કોન્સ્ટન્ટ સ્પ્રિંગ માટે જ હોય, એવું ના હોય. જે કોઈ બી SHM કરે સ્ટુડન્ટ્સ, એના માટે તમે સ્પ્રિંગ કોન્સ્ટન્ટ ડિફાઇન કરી શકો, રાઈટ? ચલો, જે બી કોઈ બોડી વિચ પરફોર્મ SHM, then we define spring constant for it. Now we want to find spring constant of wire. So here torsional spring constant alpha of wire. So see, what is the formula? 2 pi under root I by alpha, because તમારા મગજમાં યાદ રાખવાનું, for linear SHM T is equals to 2 pi m by k. So here instead of m we write I, and instead of k we write alpha. 2 is equal to 2 pi under root I by alpha. Chalo, so now we want to find alpha. So take alpha as a subject, so square on both the side. So alpha is equal to 4 pi square I upon T square. Now see, what is the moment of inertia for disc? Now disc is rotating about its center because wire is connected with center. So for disc, what is the moment of inertia about its center? mr square by 2. Right now, and students, radius of disc is 15 centimeter, that is given 15 centimeter. Chalo, so now place all the value. So for what is the value of pi square? 10, है ना? What is the value of pi square? Always remember pi square is 10. Chalo, so divide into mass. What is the mass? 10 kg. What is the radius? 15 centimeter. And divide by time period. What is the time period? 1.5 second, and t square 1.5. So we write 15 into 10 raised to minus 1. Divide by 2. So 15 square cancel. 4 by 2 2, 10 raised to 2, minus 2 into 2. So minus 4, minus 1 into 2. So 2 minus 4 minus 2, that is cancel. So what is alpha? 2 Newton meter. Okay, for easy calculation always take pi square equal to 10. Okay, so for easy calculation always we take pi square equal to what? 10. Right, always take pi square equal to 10. Chalo, so question is easy. So remember formula for angular SHM. Chalo, now students, we want to find next, it is a extra topic but important. See spring. Now we want to find spring constant of wire in terms of Young modulus. Spring constant of wire in terms of Young modulus. So, spring constant of wire in terms of Young modulus. Spring constant of wire in terms of Young modulus. Chalo, so how to find students? See, so spring constant of wire in terms of Young modulus. See students, this is the wire, very thin wire attached with the block of mass m. It is wire, not a spring, and it when oscillate, when slightly released, and it perform SHM, right? Chalo. Now see students, suppose what is the increase in length of wire? Delta n. Okay, when block what is delta L? Increased in length of wire okay, so instead of F is equal to Kx, here we write F is equal to K delta. because when as we know, when block is connect with spring, then spring is also extend. So here wire is extend by amount of delta L, very small amount but હોઈ શકે extension થોડું. Now see students, now we define young modulus. I think તમને યાદ હશે, but no યાદ હોય તો એ કરવાનું છે આપણે. It is a part 2 chapter. So young modulus means longitude, it is a ratio of longitudinal stress by longitudinal strain. Okay, young modulus is a ratio of longitudinal stress by longitudinal strain. હવે longitudinal stress એટલે F by A. ખાલી ફોર્મ્યુલા યાદ રાખજો સ્ટુડન્ટ, after that we discuss in detail. So what is the longitudinal stress? Restoring force per unit area, and strain means change in length upon original length. So FL by A delta L, this L is in multiply, so FL by A delta L. What is F A delta L? Sorry, K delta L. Restoring force is what? K delta L. Kx boy, but here we write K delta L because delta L is what? Change in length of wire. So delta L cancel. So young modulus is what? KL by A. So what is the spring constant of wire in terms of young modulus? YA by L. What is the spring constant in terms of young modulus? YA by L. Okay, so what is the spring constant students? YA by L, young modulus into cross section area divided by L. So now what is its time period? T pi, it is SHM, so we write M by K. SHM હોય તો તમે લખી શકો time period T is equals to 2 pi under root M by K, and it is a linear SHM. Okay, SHM. Now what is K? YA by L. So what is the time period? ML upon YA. Okay, this is the time period of wire, ML upon YA. Y means young modulus. Chalo, now see students, one question based on this. Chalo, see what is that question. First, this is the length of wire is what? L. What is the young modulus of wire? Y. Now this wire is connected with the spring of spring constant K and with the block of mass M. Okay students, so see wire is connected with the spring, and both are connected, wire and spring both are connected with block of mass M. And again it perform what? SHM. Again it perform what? SHM. So we want to find its time period. Okay, and what is the cross sectional area of wire? A. Chalo, so T is equal to, what are the option? First option 2 pi under root m by k. Second option, okay students, so we want to find correct option. First, see what is the first option, student. First option is what? 2 pi under root m by k. This option is correct when spring is connected only. When only spring is connected with block, then this is the option. But here's both spring and wire. Same, this option is true when only wire is there. See, when only wire is there, then we can write 2 pi under root ml by y. But here both spring and wire, so this option is also wrong. So now two options are left, B and C. Chalo, so for wire, for wire, what is the spring constant, students? For wire, spring constant is what? YAL. Okay, for wire, what is the spring constant in terms of Young modulus? YA by L. Okay, chalo. See here also options are in terms of Young modulus Y. Now for spring, what is the spring constant? K. That is given, students. Chalo, okay. Now see, both are connected in series. How to know both are connected in series? Because block is connected at the end. Block is connected at the end, so it is in series connection. If block is connected between wire and spring, okay, here hoy block, then it is parallel connection. But now block is at the end, so it is series connection. And for series connection, what is the equivalent spring constant? What is the equivalent spring constant? Reciprocal addition. What is K? See, first simplify it. First take LCM. K2 plus K1. So K dash is equals to reciprocal. So K1 K2 upon K1 plus K2. Okay, gonna direct याद राखी लाई in numeric for series connection, in numerical multiplication, in denominator addition. K1 K2 upon K1 plus K2. Now what is K1? Y A by L. What is K2? K. Y A by L plus K. Take LCM. So here it is multiplied, but here addition. So when we take LCM, then LL cancel. So what is the effective or equivalent spring constant? YAK upon YA plus K. So this is the equivalent spring constant. Now what is the time period? 2 pi under root m by K dash. What is K dash? YAK. Now this is in multiply. So YA plus KL upon YAK. Okay, so option B is correct. Okay students, so now in next lecture we discuss different types of SHM. Okay, SHM motion in case of YouTube, in SHM motion in case of change in pressure, change in volume. Okay, we discuss different type of SHM motion.